Are we recording? Oh, we are recording. Okay. Hi, everyone. And welcome to Math 7 Accelerated, the Flipped Classroom. It's a lot of writing.
It is.
The Flipped Classroom. Okay. So there we go. So first thing we want to do is our first lesson we're coming to is called a plan for problem solving. A plan for problem solving, and that's going to be our first one. And whenever you're solving a problem, it is so helpful to have an organized plan to solve the problem. You know, following steps that will make the problem easier for you. And so what we're going to do is give you this 4-step plan. Real simple. Step 1 is understanding. Understanding, get a general understanding of the problem. What is the problem saying to you? What is it looking for? What are you trying to find?
The second step after understanding is to plan. What you want to do is to make a plan to solve the problem and get a general estimate of the solution. You need to start to think about what steps you're going to take to get to that solution.
The third step is to actually solve. You're going to use your plan and you're going to solve the problem. Come up with an answer that you think is the right solution to the question.
And the fourth and last step is check. You should always check your answer, to check to see if it makes sense, if it's reasonable in the given situation, given that problem. Sometimes your answer may be the solution to a variable, and you can just plug that back into the original problem to see if it fits. So you should always check your answer to make sure it's correct.
So let's go through an example here. So according to a recent study, 1 out of every 10 people is left-handed.
And I had dinner with 3 of them yesterday. I really did. They're all in one family. 3 out of 4 of the family. So obviously they weren't statistically representative of the fact that 1 out of every 10 people is left-handed. But really, 3 out of 4 of them were left-handed.
Are you one of the left-handed?
No, I was not.
Either am I. So
No.
so we're well, now that's out of 5 people.
We're evening things
we're
out
coming
now.
up to it, yes. But if every 1 out of 10 is left-handed, if there are 172, that's a 2, people in the 7th grade, if there are 170 people in the 7th grade, predict the number of students who are left-handed. So again, 1 out of every 10 people is left-handed. If there are 172 people in the 7th grade, we want to predict how many of those students are left-handed. So what should we do first here?
Well, first we need to understand what's going on in this problem. We know 1 out of every 10 people is left-handed. We also know there's 172 people in the 7th grade. So that information is what we need to understand in order to proceed with this problem.
So that's the important information that we need to know.
Yeah.
Okay.
And we also need to know what it is we're trying to find out. It's how many students are left-handed. That's the question.
That's what we want to know. There should be a big question mark there. How many are left-handed? Okay. So we could think of different ways of doing this problem, kind of making a plan And there's all different ways, and that's something we're going to work on all year long, are different plans that we can use. But in this case, I think a good plan might be to make a table. What do you think?
I think a table would be great.
I think so.
Speaking of dinner.
Speaking of dinner,
So.
around the dinner table, let's start with the number of people, and that is number of people, not hashtag people.
Right.
So we have the number of people, and then we're going to have in the second part the number that are left-handed. Now, we know that if there are 10 people, 1 is left-handed.
Right.
So what can that lead us to?
Well, if we look for a pattern here, we could see, although it's not many numbers to make a pattern, it seems reasonable to think that if there are 20 people, twice as many people, you're going to have twice as many before a left-handed people. So 2.
So 2 would be left-handed.
2 left-handed.
If we continue that, if there were 30 people, that would probably mean there are 3 left hands.
Mm-hmm.
And let's just take this out a little bit farther. 40 would be 4 people, and 50 would be 5 people. But that's only 50, so we need to keep going, but this could be a really big chart. I wonder if there was some easier way, by looking at the chart, if there was a pattern we saw that we could use.
Well, I see a pattern. Do you see a pattern there at home? I thought so. Yeah, it looks like you could, this is what I see, you could divide any given number of people by 10 to see how many of those people are left-handed. See that?
So if we take the number of people and we divide them by 10, that would give us an approximate number that's left-handed, a good prediction. So does that work? If 30 people, 30 divided by 10, that's 3. So that did work. So then if we were able to take our 172 people and divide that by 10, then I should get about 17.2. Can you have 0.2 of a person?
No.
Nah, I don't think so.
No.
So it seems that the reasonable answer would be that 17, and let's not say people, because the question didn't really say people. The question said students. So really, 17 students would be left-handed. Well, that seems pretty easy.
It does. So we have understood the problem, we made a plan, and now we've solved it. And we need to check that. Let's just double check. Is 17, looks like you just take the number of left-handed people and multiply by 10, that'll give you the number of people total. 17 times 10, 170. That seems like it's a reasonable answer.
Seems very close to 172 to me. So it seems like we have checked and it checks correctly, and it makes sense.
Yes, it does.
All right. So let's do this. We're going to give you a question for you to try now. So look at this question. James needs to buy 1 can of orange soda for every 3 cans of cola. If he buys 24 cans of cola, how many orange soda should he buy? So here's what we want you to do. Pause this recording right now and see if you could do this problem. And when you're done, start the recording again and see if your answer matches our answer. All right, so what did you get for your answer? Because what we did, we said, okay, we figured out that there was cola and there was orange. And we knew that for 1 can of orange, he bought 3 cans of cola. And we just kept our pattern going here. So for 6 and 2, and 9 and 3, and we kept going all the way out, and notice the pattern that it looked like that we could take the number of colas and divide it by 3.
That's what it looks like.
So if we did that, we figured out that if we have 24 cans of cola divided it by 3, we would need 8 cans of orange soda. Did you get 8 cans of orange soda? Yeah, I thought you did. Very good.
Good job.
Now, one more for fun that you'll see periodically. Look at this problem. If we gave you this pattern, 2, 6, 18, 54, and 162, could you tell us the next term in that sequence? Pause the recording and see if you could come up with the next term in that sequence. So, Mr. D'Elia, what do you think the next term is going to be?
Well, here's what I'm seeing here. The other patterns we did all had to do with adding. Like, for example, with the cola there, I see I'm adding 3 to the 3 to get 6, and I'm adding 3 to the 6 to get 9, and I'm doing the same with the orange, except I'm adding 1. But in this pattern, I'm not adding. So I got a couple of other operations I can think about. Could be subtracting, but that's not what's happening here. Dividing, but no, the numbers are getting bigger. I think I'm multiplying. Looks like if I multiply 2 times 3, I get 6. Let me try that with the 6. 6 times 3, that makes 18. So I'm on the right track. 18 times 3 is 54. 54 times 3 is 162. So, if I multiply 162 by 3, I should get, what's that, 486?
I think so. So did you get 486 for yours? Good. By the way, did people laugh at you talking to your computer screen? I thought so. But then again, we're sitting here talking to an iPad, so don't feel too bad.
Yeah.
So that actually brings us to the conclusion of the lesson. What we want to do, though, is we're going to give you a question here. And with this question, you're going to work on it, but we're not going to give you the answer. You're going to take this question, you're going to do this question now, and you're going to bring it into class tomorrow. And then we'll tell you what the answer is, and we'll go over that with you. And we'll see if you got it right. If you have any other questions from tonight's lesson, let us know in class tomorrow, and we'll be more than happy to answer those. All right, we'll see you tomorrow.
See you tomorrow.
So your question is the following. A cookie shop offers 6 varieties of cookies and bakes 5 dozen of each kind every day from Monday to Friday. How many cookies are baked in 4 weeks?